Hello, we are now looking at chapter 10, which is about hypothesis testing. In chapter 8, we learned the methods for estimating the population mean and the population proportion. If you recall, at the beginning of chapter 8, I mentioned that from here we are starting what we call the inferential statistics. So there are two main main activities in inferential statistics, and one we did in chapter 8, which was the estimating the population mean, population portion, and finding the size of the sample needed. So now we are going to start in chapter 10. We will focus on the second major activity of inferential statistics, and which is testing claims made about population parameters. So this is called the hypothesis testing. Now we will restrict ourselves to the two parameters, which are the population mean and the population proportion. So section 10.1 is about the fundamentals of hypothesis testing. So in this section we will learn the vocabulary and the key components that we will need in future for a hypothesis test. So we dig in. So what is a hypothesis? In statistics, a hypothesis is a claim or statement about a property of a population. Okay? Hypothesis test. Hypothesis test, or a test of significance, so this is another name for the same thing, is a procedure for testing a claim about a property of the population. So the claim that we are talking about this here, so it is just the hypothesis test is to test that claim. So what is the procedure? These are four main steps, but we have to go into details of this test, which we will do as we do the examples. But first thing is to state the null and the alternative hypothesis. So you have to first understand what is a null hypothesis and what is an alternative hypothesis and how do we write them. Then determine which distribution to use for the test statistics and state the level of significance. Now distribution, mainly we have done the normal distribution, and now at the end of this chapter 10 you will learn something we call chi-square distribution. So whether we are using the normal or the chi-square, that you can mention and then state the level of significance. Now what is the level of significance? That will also come in the definition later, but this is something we already know, we have already seen before. Okay, number 3 part is to gather the data and calculate the necessary sample statistics. So this is the calculations or the computations we will do, and then draw a conclusion and interpret the decision. So draw a conclusion and interpret the decision. Now for the conclusion, you will see there are two choices. We have to choose one of them, and the interpreting the decision is also very crucial. It should be, it's very easy to interpret it in a wrong way. So make sure that you learn the correct way of interpreting your decision. So okay, we will start with the definition of alternative hypothesis. So the alternative hypothesis denoted by H sub A. So H uppercase A and then uppercase H and lowercase a, and or sometimes we refer it to H1 and then, or in some books it is uppercase A. So it is a mathematical statement. Okay, mathematical statement, not in words. In chi-square you will see sometimes we have some portion in words, but in the here in the beginning we are saying it is a mathematical statement that describes a population parameter, and it is the hypothesis that the researcher is aiming to gather evidence in favor of. It is also referred to as the research hypothesis. So sometimes we call it the research hypothesis. So what is the null statement? The null statement hypothesis denoted by H sub 0, the H A alternative hypothesis has these three versions, but the Ash is null hypothesis has only one way of writing. Is the statement that expresses the value of the parameter currently believed to be true, and it will always be a statement of equality, so it will always have just equal to sign. The alternative hypothesis never uses the equal to symbol. Okay, the equal to symbol is never in the HA, but previously, a few years back, the statisticians were using a slightly different way of writing the null hypothesis, but now they have concluded, or they have come to this decision that they are all just going to use the equal to sign in the H, so the null hypothesis. Okay, so let's look at some examples where we are going to see what the null hypothesis is and what the alternative hypothesis. So it's example 1 says at Northwest Mississippi Community College, syllabi for online classes state that students should expect to spend 10 hours per week doing coursework for each 3 credit hour class. The director of e-learning for the community college is concerned that the students are being required to spend more than 10 hours, okay, more than 10 hours per week for each 3 credit course. Okay, so we basically have to write the null and the alternative hypothesis. It doesn't matter which one you write first. Some people just write because H sub 0 is going to first. Okay, the first thing you have to look upon is what population parameter are we talking about. So when we said 10 hours per week, what is this? This is the average, right? When we say to spend 10 hours per week doing coursework, so on the average 10 hours. So it means we are talking about mean here. So our H sub 0 will be that mu is equal to 10, and H sub A will be that mu. Okay, so what is the e-learning, the director of the e-learning for the community college, what is he thinking, or what he is claiming? He is claiming that the students are being required to spend more than 10 hours. So his hypothesis is the mu is greater than 10 hours. Okay. So this is how you will figure out the hypothesis. Second example, after learning that Peter Collat of Switzerland could hold his breath for 19 minutes and 21 seconds underwater, a group of students decided to conduct their science fair project around the amount of the time an average adult can hold his or her breath. Part of the group found research to suggest that adults can hold their breath for 30 seconds when submerged in lukewarm water. The other half of the group found evidence to suggest that the mean time is different if the water temperature is colder. Okay, now what are we talking about? So H naught HA. Okay. What are we talking about here? So it's holding the breath, right? 30 seconds. Is it a proportion? Because remember, our hypothesis will be about the mean or the proportion. So are we talking? Do you think we are talking about mean, or are we talking about proportion, population proportion? Well, I see the word mean here, so it means so it is mu. Okay, this will always be equal to a number, not 0. Sorry, equal to what? So can you see it says the one half found that so this is kind of already found research. So it means this is the kind of currently believed value, right? So mu is equal to 30. But now what is the other group? What did the other group found? They found that people can hold more than 30, less than 30, or what? So but it's saying is different. So it could be less than, it could be greater. So what does that mean? It is not equal to 30. Okay, next one. A leading news authority claims that the president's job approval, so this is a claim, news authority is making the claim, approval rating has dropped over the past 3 months. Okay, so previous polls put the president's approval rating at a minimum rate of 56%. Now note here, you will not see the word mean anywhere in this question, in the wording of the question, and then we are looking at a percentage. So what does percentage tell us? That it is a proportion problem. And then also approval rating, it cannot be a mean, right? So it has to be a proportion. So we have H naught, HA. Okay. So previous polls put the president's approval rating at a minimum rate of 56%. So this is kind of the current rate, which is they think is true. So it is 0.56. Sorry, we'll say P equals, little p equals 0.56. Okay. And then the president's chief of staff is concerned about this news report, since it is an election year and he wants to run a test on the claim. What is the claim? That it has gone down, so it may be, this is less than 0.56. The next one, a survey of Super Bowl viewers found that 8.4% said that they were influenced to buy products from companies that advertise during the game. Again, percentage, so it's about P. So what is the H naught? H naught is that P is equal to 0.084, 8.4%. So HA, so we will have P, and over here we will have 0.084, but what symbol goes? So it has to be one of these, less than, greater than, or not equal to. These are the only three choices that P, the HA, P in the HA can have. Okay, so it says because of rising costs, one company president has threatened the advertising team with not renewing the Super Bowl ad spot unless they get the results they want. He says that unless their company's ad stimulates at least 8.4% of viewers to buy products, then they will not be airing an ad during the Super Bowl next year. So his claim is that the P is less than 0.084. Okay, so once you figure out or you understand how to write the null and the alternative hypotheses, then we move on to learn how to, what is a statistic and how do we compute it. So a test statistic, so we call it test statistic, is the value used to make a decision about the null hypothesis. Okay? It is found by converting the sample statistics, such as the sample mean or the sample proportion, to a score such as the z-score, okay, with the assumption that the null hypothesis is true. So there are other type of scores as well, but we have not learned those other distributions, so we cannot find any other. Like there is a t distribution, so relative to that there is a t-score. We have not done that, and the chi-square we will do, but that will come later in this chapter. Okay, and we all the time we assume when we run the test, do the hypothesis testing, we are assuming that the null hypothesis is true. Okay, level of significance. So level of significance denoted by alpha. Alpha is the probability of making the mistake of rejecting the null hypothesis when it is true. This is something we call it error. We'll talk about later in this section. Okay, this is the same alpha introduced in chapter 8, where we define the confidence level C for a confidence interval to be the probability 1 minus alpha. So see, we have C is equal to 1 minus alpha. Now the common choices for alpha are 0.01, 0.05 and 0.10, but 0.05 is the most common one. Now why did I mention these? Because it's often in the problem they will mention the alpha, so or C, one of them will be mentioned, so you can find the other. But if it is not mentioned, then 0.05 should be taken, should be used, or can be used for alpha. Okay, so this is like a repetition. Okay, here alpha is the same as where C is the level of confidence learned in chapter 8. Okay, now what do we say? This is like a definition of statistically significant. We say a sample statistic is said to be statistically significant if it is far enough from the presumed value of the population parameter to conclude that it would be unlikely for the sample statistics to occur by chance if the null hypothesis is true. Conclusion for a hypothesis. So what is the conclusion? These are the two conclusions. Okay, you will use one of them. So one is reject the null hypothesis. So it means you found evidence that suggests that the null hypothesis is not true. So we will reject the null hypothesis. This is kind of, these are the exact words you have to write. And the other is, if you are not rejecting the null hypothesis, you will not say that accept the null hypothesis or reject the alternative hypothesis. No, you will not. We will say fail to reject the null hypothesis. So this is kind of a vocabulary. This is kind of a strict, emphasis on this, that these are the words that should be used. Now note, the hypothesis test is never proves that either hypothesis is true. It can only say that either the evidence is strong enough to contradict the null hypothesis in favor of the alternative hypothesis, or the evidence is not strong enough to contradict the null hypothesis. Now first, these words, either this or this, whichever is this, and then in order to explain them, so in order to explain the first one, you can write this, and in order to explain the second, you can write this. So now interpreting the conclusion to a hypothesis test. Okay, so the campaign manager for a gubernatorial candidate believes that her candidate connects with a younger audience and will draw a larger voter turnout for the 18-24-year-old demographic. Historically, only 25% of the eligible voters between 18 and 24 years old vote in the election. The result is to reject the null hypothesis. Does the conclusion support the manager's claim? So first, in order to answer this, we should know what our HA is and what our null hypothesis and what is our alternative hypothesis. The null hypothesis will be, so percentage P equal to 0.25, and this campaign manager is claiming that P will be greater than 0.25, right? Okay. So this is the hypothesis, and then it says the result is to reject the null hypothesis. Reject the null hypothesis. This is the conclusion. Now the question is, does the conclusion support the manager's claim? So yes, it does, because we are rejecting the null hypothesis, which said that the total proportion is 25%, but the campaign manager said it will be more than 25%. So yes, the conclusion supports the manager's claim. Second example, based on historical data, the Board of Education for one large school district believes that the percentage of high school sophomores considering dropping out of school is at least 10%. At least 10%. Okay. A high school counselor in the district claims that this percentage is too high. Okay. A hypothesis test with alpha equal to 0.02 is performed on the counselor's claim. Okay, counselor. So what is the counselor's claim? That the percentage is too high. The result is to fail. The result is to fail to. Okay. So first we write our H naught and HA. So what do you think? So I'll let you think for a couple of minutes. Okay, so we have P equals 0.10, is too high, so it will not be. Reading again, P should be great. That is what the counselor's claim is, right? Counselor is claiming that this percentage is too high. Okay, so it is not 10%; it's more than 10%. It's high. So the result is to fail to reject the null hypothesis. So fail to reject the null hypothesis. In other words, we are accepting the null hypothesis, which means we are the other hypothesis is rejected. So we will say no. The findings do not support the counselor's claim. Okay, so now we talk about types of error. Now if we fail to reject the null hypothesis, then we cannot say that the null hypothesis is supported. As I mentioned earlier, we can only say that the evidence does not support the alternative hypothesis. Okay, it is important to remember that no matter what the conclusion is, neither hypothesis has been proven. Now we talk about types of errors in hypothesis testing. When performing a hypothesis test, there are two types of errors possible. So rejecting a true null hypothesis or failing to reject a false null hypothesis. We call rejecting a true null hypothesis RTN, rejecting true null hypothesis, a type 1 error. So if we made this error, we rejected a true null hypothesis, then it is a type 1 error. So here there is a small table which is also available in the formula sheet. So if you are rejecting the null hypothesis where null hypothesis was true, we made a type 1 error. And if we rejected the null hypothesis while the null hypothesis was false, then it is a correct decision. The other type of error can be fail to reject H0 when the H0 is true. Right? So if H0 is true and we fail to reject it, then it means we kept H0, it means correct decision. But if H0 was false and we fail to reject, so then it's called the type 2 error. Okay, so now examples where we have to determine what type of error has been made. So example says a television executive believes that at least 99% of households in the United States have at least one television. An intern at the executive's company is given the task of using a hypothesis test to determine whether the percentage is actually less than 99%. Okay, so this will H0. So H is T is less than 0.99 and the H0 will be T is equal to 0.99. Okay, the intern decides to the hypothesis test is completed, and based on the sample collected, the intern decides to fail to reject the null hypothesis. So he fails to reject the null hypothesis. It means he did not find evidence to reject the null hypothesis. In reality, 96.7% households own a television set. Was an error made? If so, what type? Okay, let's see. Real value of P is 0.967. So is this value less than 0.99 or more than point? This is less than, so this is less than 0.99. Okay, which means what does that mean? It means it is the executive's claim was correct, right? So it should have rejected the null hypothesis, or they failed to reject the null hypothesis while the null hypothesis is true. So this is a type 2 error. Next Next example, insurance companies commonly use 1000 miles as the mean number of miles a car is driven per month. One insurance company claims that due to our more mobile society, the mean is more than 1000 miles per month. The insurance company tests its claim with the hypothesis test and decide to reject the null hypothesis. Okay, first we write our HA and H sub 0. So now it is about mean. So mu is equal to 1000, and this will be mu is, because see it says the mean is more than, so it will be greater than 1000. Okay, so and decide to reject null hypothesis. So decision, reject H, I can just say reject H naught or null hypothesis. And then in reality or real value, is equal to 1250 miles, right, which is more than 1000 miles, right? So it means the insurance company was correct. So reject the null hypothesis. Yes, the correct decision. So no error. Okay, this is the last question. A study on the effects of television viewing on children reports that children watch a mean of 4 hours of television per night. Okay, mean. So H A H 0. We are talking about mu, and this looks like mu is equal to 4 hours. Okay. So Kiko believes that the mean number of hours children in her neighborhood watch television per night is not 4. Okay, not 4. So what does that mean? It is different than 4 days. It's not saying it's less than or greater than. Well, she's assuming it is not 4. So what will we say? HA is mu is not equal to 4. She performs a hypothesis test and rejects the null hypothesis. So reject the or reject H naught. Okay, and then actual value is equal to 4. Assume that in reality children in her neighborhood do watch a mean of 4 hours television per night. Did she make an error? If so, what type? So what did she do? She rejected H naught while H naught was true. So what is that? Type 1 error. Okay, so this is how you do these problems, and I will see you back in section 10.2 in another video.